Good evening, everyone. Welcome back to Fire Alarm Level 1, now taught in the daylight. Tonight, we are talking about signaling devices, right? We've already talked about initiating devices. That took two whole eternities to get through. Now we're talking about signaling devices. Luckily, signaling devices not quite as horrifically detailed as initiating devices, so that is joyful. And then after that tonight, we're going to be talking about the assignment, right? And we'll be reviewing what actually has to get done on the assignment versus what you have in your books. But we have to learn about signaling devices first because signaling devices are part of the assignment. So our signaling devices. We have various types of audible signal devices. We have various types of visual signaling devices. There is not yet any there's not really any other types of signaling devices out there yet. We don't have any smell-o-vision stuff happening or anything like that. There's nothing that's being directly injected directly into our brains. We don't need to do that because we have, eyeballs and earballs so that we can do that ourselves. They function completely differently from initiating devices. So we're going to talk about that. And of course, we have completely different rules for our signaling devices. So we're going to be talking about that as well. So let's start with, well, what is a signaling device? It's any device which, when activated, produces an audible and or visual signal that notifies occupants of a fire emergency condition or evacuation. Right, these are outputs of the fire alarm system versus all our initiating devices, which are inputs. And they get connected to the fire alarm control unit on supervised NACs, notification appliance circuits. Of course, it has to be supervised because, well, we need to know that they're going to be functional. We need to know they haven't been removed because that's a huge issue. Well, people don't like being bothered. Right? We have a huge range of alarm signal devices that can be used. Uh, a lot of the stuff has been tweaked from manufacturer to manufacturer, depending on what they're exactly looking for. But most of that really is stylistic at this point. They all function essentially the same. We have to remember that we have our two different types of signals. We have our alert signal, that is the first stage of a two-stage system that's going to advise people of a fire emergency. And then the alarm signal is telling us to evacuate the building. And that tells everyone in the building, you have to get out. A fire emergency exists. Like first stage and second stage. So audibility wise, right, our audible signal devices, bells, speakers, horns, chimes, and then visible devices, we have strobes and directional signs, including fire, do not exit. And then we can get combination devices. You can get combination horn strobes, combination speaker strobes. You cannot get combination bell strobes. They don't exist. According to S524, they audible and visible signal devices have to be supported independently of their attachments to the circuit conductors. We've got to mount them on boxes. And we have to install enough of them because we have to meet the audibility requirements and the visibility requirements. If we might need only two or three in a building, we might need 2,000 or 3,000 in a building. Just depends on the building. A number of years ago, I did the fire alarm upgrade to Hamilton General Hospital. It was a fire alarm system was done in 1989, and it badly needed to be redone. We did not remove any speakers. We reused all the speakers, but we also added 1,800 speakers to the building. It took quite some time, but we were looking at increasing audibility and intelligibility. But we'll talk about that when we get to speakers. We have to install them in accordance with manufacturer's published installation instructions. Uh, Certain devices, it's very particular on where they get installed. And we have to have the same sounds and sound patterns when activated. We can't mix bells and horns in the same building. Everything has to sound the same. So our NAC circuits, notification appliance circuits. Yes, NAC circuit is a little bit redundant, but yeah, you gotta bear with me on that one. The NACs. Um, we still put an end of line on them so that we can confirm our continuity because we need to make sure that we have connections to all the notification appliance devices on the circuit, make sure they're all connected, nothing's been disconnected, so that everything's going to work. So we're going to supervise. Just like this. They can be wired class A or class B. Vast majority of the time, we wire them class B with specific exceptions. There is a limit to the maximum number of devices or the maximum circuit loading. Strobes are notoriously power hungry. Even now that all the manufacturers have finally switched to LED strobes instead of the xenons, they're still power hungry. It still takes a fair bit of power to charge those capacitors. So we have to make sure that we're not overloading the circuits, and we need to make sure that we have proper overload protection. There are fuses or circuit breakers built into the panels for the notification appliance circuits. And polarity is crucial. These are power consuming devices. So we need to make sure that the polarity is correct, especially because we have to put voltage onto the circuit to make sure that everything's connected properly. We put voltage on, our end of line resistor is going to give us a known current, and we can monitor that. So you'll observe that on this NAC circuit, we've got coils to make whatever type of a thing it is function. Well, we use coils and bells, right? We might just use a coil. We might use a motor. We'll learn about that later. But we've also got a diode built in so that we can run a reverse polarity on supervision. And then upon activation of the alarm, we run it to proper polarity, and we can get the voltage through the actual devices, and they are going to function. So that's how we supervise it without making them ring all the time. Wire size is important. We rarely can use 18 gauge on bells and strobes and horns. It's just not going to work for us. The voltage drop is going to be too much. A typical bell draws 12 milliamps. So it does add up. Once you put, 10 or 20 on a circuit, it can be a little bit too much for a 18 gauge wire. So we have our forward and reverse bias because we put diodes in so that the electrons will only go through the actual bell or horn or strobe in the one direction. It won't go through in the other because we're supervising the wiring. So long as the wiring does not get disconnected, we are golden. And then when we switch the electron flow, it's going to work because that's a diode for you. right? That's exactly how it works, right? So when we are in supervisory mode, that's just when the panel's just sitting there chugging away, watching everything. We can't get through the diodes, that's blocking the current flow. So we just send the voltage down the wires to the end of the line and back to the panel. And so long as we see our predictable uh, current, then everything is good. Upon activation of the alert or the alarm signal, we flip the polarity, and now all the bells are ringing. Advantages to this is if you hook up all your bells and one's backwards, yeah, you might just hear it ringing on reverse polarity because it can get through the diode. It might not be ringing very loud, but it'll be ringing. If we hook up strobes on a reverse polarity,
Mm-hmm.
uh, we'll actually get a short circuit fault because it'll think that it's shorting out. Right. So there's things we can do uh, to be able to figure out issues very quickly because it's designed to operate in one polarity versus the other. And well, fire alarm panels work on 24-volt DC, and most of us carry 18-volt batteries for our cordless tools. Yeah, signaling devices will run pretty good on 18 volts. So there's our test battery. We can just hook them up in one direction, make sure they all ring. If we hook up in the other direction and none of them ring, well, we hook them up properly. If you hook them up and one of them isn't ringing, yeah, we can figure out where the issue is because then we can hook it up reverse polarity and you will hear that one ring. Oh, yeah, that one's backwards. Right? We can take advantage of the design of the bells and horns and strobes to troubleshoot them very, very quickly. Fixing it is another thing, especially if you're dealing with a pile of people who are doing the connections of the devices who are, I wouldn't say color blind, but color stupid. You could get some messed up polarities here and there, and at that point, you see which direction has the fewest problems, and you make that your officially correct. Since the wire colors is just a recommendation, anyways. So to calculate the sound settings, there's a whole bunch of math that can get done. Luckily, not typically our problem. That's what the engineers are for. We just measure and make recommendations. And once we've been doing it for a while, if we have low audibility in areas, we tend to be able to see that coming up. And we know to make provisions for adding a bell so that when they give us the change order to add the bell, we can get it done nice and quickly. Because we have to check the decibel rating. We can't just go, yeah, that sounds good. We have to actually measure it. And you can't use your phone for this. Yes, we've got sound meter apps on the phones. They are not calibrated. They're surprisingly accurate, but they're not officially correct. So we have to use an actual sound pressure meter. This is part of what's done during verification. Uh, because we have maximum and minimum volumes. Right? We can't measure more than 100 decibels at 3 meters from the device. We can have a device put out more than 100 decibels, so long as when we measure 2 meters above the floor, it's not over 100 decibels. You'll see that in large open areas or just very, very large rooms like aircraft hangars and arenas and stuff like that. You need some pretty decent volume to be able to reach that whole area. So you could have some very, very large speakers or horns up in the rafters, right? And so it can be absolutely deafening up there. 130 decibels is not unheard of. But when you get down to where people are, we have to make sure that we're not more than 100 decibels because we're talking about uh, hearing damage in a very short amount of time. We also have a minimum sound level. In sleeping rooms, it's a minimum of 75 decibels, and that's when the doors are closed. And we really look at that as at the pillow, not just on the other side of the door, but at the far end of the room. We have to hit 75 decibels in buildings of residential occupancy in the sleeping rooms. That's the minimum volume. Often now you're going to see uh, speaker strobes or horn strobes installed right in the bedrooms. Right? It might be like we see here in a hallway serving two bedrooms, but depends on the layout. We could end up with them right inside. So that's maximum 100 for anywhere, minimum of 75 for building of residential occupancy in the sleeping rooms. Everywhere else, minimum of 65 decibels, but also a minimum of 10 decibels above ambient noise level. Just the noise that naturally exists when the building is just existing and the building is occupied and all that. We need to have at least 10 decibels above ambient. So if we've got a nice quiet reading room or something like that, and it's 50 decibels, we have to be at least 10 decibels above. So we need to be a minimum of 60 decibels. But of course, we have to be a minimum of 65 decibels no matter what. But if we have a louder environment, a factory floor on something like that, that's about 75 decibels. Well, we have to be a minimum 10 decibels above that, which brings us up to a minimum of 85 decibels for that area. Right, so it's ambient plus 10 decibels, but never lower than 65. And this is why we need the official sound measuring device, and we have to measure ambient noise levels and the alarm noise levels to make sure that we are meeting the requirements. If it's a very loud area, like cinemas, arenas, things like that, we could be 85, 90 decibels when things are happening in those areas. And so we could have to hit 100 decibels in that area. Of course, now we're getting a little bit on the loud side, aren't we? 100 decibels is real loud. So we have to supplement with visual signals. As soon as we get more than 87 decibels of ambient noise, we have to put in strobes as well. Or if the occupants of the floor area are using ear protective devices, right? We might only be at 70 decibels in the area, but the company policy is uh, ear protective devices have to be used. As soon as we're using ear protective devices, it needs to be a minimum. Well, we have to still keep our minimum of 10 decibels over, but we also have to put in our strobes. Or if we have occupants that are within audiometric booths or sound insulated enclosures. Audiometric booths, that's where we do hearing testing, right? I'm not sure if you guys have ever been in those. I've actually wired up a few, and I really don't care for it because it's aggressively quiet, and you can you know, hear your heart beating and all that stuff. It kind of makes me go a little squirrely fairly quickly. But we don't want to put a horn in that room because if you're sitting in a room that's only like 10 decibels or lower, right? About as quiet as you can get it. Like the loudest thing in there is your breathing. And then you put a horn in that room, you're going to be asking questions like, okay, who crafted my pants? So that's not acceptable. So we're going to put strobes in. But that's for the actually when we have people inside audiometric booths or inside sound insulated enclosures, we have to put in those strobes. The people who are outside, like the staff that is monitoring what's going on inside those enclosures, we don't have to put in strobes because, well, they're just in a normal environment, right? We also have to put in visual signals where Music and other sounds associated with performances could exceed 100 decibels. Totally makes sense. One of the things that we have to do in the shopping malls now is as every unit gets renovated and a new tenant comes in, we put in music shutdowns. So we put in a music shutdown relay so that the uh, the thumping music that's inside the store to keep all the old people like me out of the store uh, turns off when the fire alarm activates. So that is our basics of where we're putting our devices because we just have to put them where we can hear them or where we can see them. Now we have to look at, well, what do we do to make sure that people don't futz with them? Because people do that. People hate the noise. They try to silence them, make them quieter. They'll damage them. With strobes, they'll just cover them in tape or put a cardboard box over them and all that stuff. Uh, Quite annoying. But that's the stuff that we catch during our annual inspections. And if it gets bad enough, we get the authorities having jurisdiction to issue fines. But of course, we start by letting the building management know that, yeah, this office here keeps every year, you know, there's uh there's damage that's been done to the speaker. You might want to have a chat with that person. It can be pretty funny too, because they start talking about permanent hearing damage and it's over ambient and all that. And then you get out your meter, like, oh no, look, it's too quiet. I've got to turn it up, which brings me a lot of joy because, well, I really don't like people. So one of the things that we have to do, because a lot of people think about themselves versus thinking about other, individuals in this lovely community that we live in. Uh, in residential occupancies, we have more stringent rules. Uh, so our audible signal devices have to be connected to the fire alarm system. Yeah, because we're looking at the building code now. And they have to be connected to the fire alarm system in such a manner that a single open circuit of one device will not impair the operation of other audible signal devices on the same circuit that serve other dwelling units or suites of residential occupancy. Right, so that's the first chunk. So the horns inside the apartments, we have to wire them as a class A so that if angry neighbor Bob disconnects their horn because they keep getting annoyed, we're not going to affect the other residents. Right? So that angry neighbor Bob is not putting them in danger. And to make sure of that, the signal circuits that are not connected to devices in the dwelling units have to be on different circuits. Right? So the signal circuits in the corridor need to be on a separate circuit from what is in the residential occupancies. And so we get a mixture of Class A and Class B in the buildings. So we'll have Class A circuits doing the actual suites of residential occupancy. And then typically we'll have Class B circuits in the corridors because we don't need Class A for that. So let's economize a little bit on the cost of construction. The other thing that we used to do is put in say suite signal silencers. So there'd be a button uh, in the suite. It might be right on a horn or it could be a separate button. You could press a button and it would silence the signaling devices in your suite for 10 minutes. So, repeated false alarms, you could silence it and off you go. So you could just choose to ignore. what you perceive to be false alarms. Now, that can cause a lot of issues because people just start ignoring the fire alarm, and well, that's how fire deaths happen. So, not ideal, but it is absolutely permitted. But instead of doing that, what the more common method now is, and mostly as a result of damage, because angry neighbor Bob, he keeps getting these false alarms and all that stuff, and so he just takes the boots to the horn in his unit and causes a lot of damage. It gets expensive. So what we're allowed to do instead, and this is typically what we're doing these days, is if the fire alarm activates, all the horns in the suites, right? I'm saying horns, but it could be any sort of uh, audible device. All the horns in the suites will sound for 60 seconds, and then they will automatically silence unless the source of the alarm is on that floor area. So if someone pulls a pull station on the seventh floor, down on the fourth floor, you get 60 seconds of horn, and then it silences for 10 minutes. After 10 minutes, if no one has acknowledged and silenced the uh, alarm signal down at the panel, then it'll start up again. Right, but it's going to do that automatically. Now, if someone on the seventh floor pulls the pull station, the horns on the seventh floor are going to keep going. Right, so that is a way of making people want to leave because they cannot silence it. When we had the sweet signal silencers, fire alarm could go off in the apartment next door, and angry neighbor Bob could just silence it and go back to bed. And that is definitely not a safe environment. Regardless of whether it's been silenced or not, if we're using voice communications, like speakers and microphones and all that stuff, if someone keys the microphone to make announcements to the entire building, it's going to go through, even if the signaling devices in the units have automatically silenced, they'll turn back on. One of the things that we have been working towards is standardizing. Just like 2012, we switched to the Running Man exit signs, right? So any exit sign installed after 2012 has to be the Running Man, which puts it in uh, not compliance in it matches the rest of the world. Not every country has adopted this, but most have. United States, of course not. But and I don't think Russia has either. And there's going to be a few other weirdos. But the vast majority of the world is now using Running Man exit signs. It's great. You can recognize it anywhere. You don't have to worry about what language it is. Uh, as someone who has occasionally worked in federal buildings, you don't need the exit sorties, which are 2 feet wide and special order, and half the time they arrive damaged. Right, so it's just a cleaner look. I much enjoy it. In the same concept, we're also working towards changing the sound patterns. We're trying to standardize the sound pattern across the entire world. We're not going to get the sounds that are the same. Our horns sound very different from European horns, which sound different from horns that are used in Japan, right? Different sounds. But the pattern is the same. It's we use the temporal pattern. That's what we are required to use uh, for all new installations. And this is not a recent thing. This has been for a very long time. Uh, for the alarm signal. The alarm signal, so if it's a single stage system, you pull the pull station, this is what you get. On a two-stage system, when you hit the general alarm key, this is what you get. It's the evacuate the building sound, the alarm signal. It's going to be the temporal pattern, which is that 3-3-3 pattern. Right? Three horn sounds, then a gap, and then three horn sounds. It's called the temporal pattern. A lot better than continuous pattern, uh, because a continuous bell can be really hard to speak over if you're trying to give instructions to, say, a bunch of grade 1 students. The temporal pattern, while just as loud, is easier to hear other things as well. Uh, Typically, what we use for the first stage is something like a 20 beats per minute. So it's very slow in comparison. So it's got kind of a chill sound to it. It's like, hey guys, stuff's going on. Pay attention to what's going on. If you see a fire, run away, all that stuff. But it's not and evacuate the building. So it's annoying, but it's not really designed to make you feel the absolute need to exit the building. We can still program fire alarm systems to do other uh, sound patterns, but that's pretty much what we're limited to at this point here in Canada. Now, all our fire alarm systems are also sold in the US. Everything that we have up here is sold in the US as well. And they have different requirements in different cities and counties and states. So there's a lot of other options as well. We do have different sound level settings. Sometimes it's controlled by the actual fire alarm panel. Sometimes it's controlled by a toggle switch on the device. Sometimes it's not controllable at all. Right? But typical high and low is 93 decibels and then about 87 decibels. That's pretty much standard. Of course, anytime that we're getting a decibel uh, decibel level written down for us, whether it's in a standard or it's in manufacturer's documentation, it's measured 3 meters from the device. Right? We don't go right to the device. We measure at 3 meters away. This is our typical ambient noise levels of audible signal devices at 24 volts. Right? Mechanical horns sit about 92, electronic horns sit about 96 decibels, bells between 85 and 92. Of course, this is for a 6-inch bell, not a 8, 10, or 12-inch bell. They are definitely louder. Uh, but you can see they're all pretty close to the same. Relatively, and this, of course, is relatively accurate because we get the reverberations and the echoes and the sound absorption depending on what the rooms are are made of. And we can use this to figure out, do we need to have it set at high or low? Of course, that's kind of a little bit of guesswork. I leave everything at high unless it's a small room, right? If you're in the room, like, yeah, this room's like 8 feet square, like, yeah, I'm gonna want it on low. But usually I just leave everything on high. So I'd rather have to turn things down than turn things up because it's much more rare to have to turn things down than to have to turn things up. So less effort for me. Sometimes we have larger rooms, we need more devices. And so we have to be careful at that because if you look at this room, we look at the overlaps of the 3 meter and the 6 meter ranges. When we do our audibility testing, we're going to be testing in the corners of the room, and we're going to be testing out in the middle of the room to make sure that we don't have just absolutely deafening spots, which it can happen. right? Sound travels in waves. It does, odd things. So we've got to be mindful of that. And down hallways, sometimes we're going really, really far between devices. Uh, Generally speaking, you know, at a 6 meter wire 6 meter wide corridor, which is 20 foot wide corridor, fairly wide, we can go like 48 meters between devices and 24 meters from the end to get adequate coverage. If you think back to, well, depending on your guys' ages, you might not be familiar, but older apartment buildings. In my youth, I delivered newspapers and stuff, so I was in and out of a bunch of apartment buildings, and an apartment building that'd be like 200 feet long. Uh, there'd be two bells in the hallway on each floor, and that was it for signaling. Right? Of course, this was back in the 80s. So the world has changed, but you put two 12-inch bells in the hallway, you get pretty good audibility right down the hallway, and it's not even that bad in the units. Definitely not 65 decibels, and especially not 75 in the bedrooms, but it was pretty good. If you can get some pretty good coverage uh, down things like hallways and in larger rooms without having to put a stupid number of devices in until you get to speakers, because as soon as you get voice involved, you have to put a lot of speakers in so that it's still intelligible. Derating of decibel levels, yeah, that's not really a thing that we do. That's more of an engineer's problem, uh, because we're not going to be doing calculations on the exact design of the wall. And okay, so this is a 6-inch wall with 5/8 drywall on either side, and rock solid insulation inside, so it's going to attenuate the sound by this number of decibels. Yeah, that's not an us thing, right? That is totally an engineer's responsibility for designing it. We're responsible for installing it and testing it. Right? But if you look at here, an open door, we lose 8 decibels just because the door, is only part of the wall. But if you look at a 12-inch masonry wall with gypsum board on both sides, we lose 50 decibels, right? Because that's 300 millimeters of masonry. It's going to absorb a lot of noise, especially when you put gypsum board on both sides, right? So we need to be aware of the concepts, but definitely not doing the calculations. That's a no. Once you've been doing this for a while, you'll be able to look at the drawings and go, yeah, it's going to be too quiet in this room. And you'll know where it's going to be an issue. Of course, we have to be mindful that uh, well, sound travels in waves. And so if you're around the corner or even just off to the side, it's definitely going to be much quieter. So all the duration stuff, yeah, flip through it in your own convenience if you feel interested, but day to day or year to year, it's really not going to matter. Same thing with ambient noise levels. You got to remember, the busier the place is, the louder it's going to be. Factories are loud, offices are quiet, and then you have everything in between. Of course, department stores, supermarkets, all that can get quite loud, especially depend the sound absorption. Right? A supermarket, it's tile or concrete floor. Uh, it's usually a wide open ceiling, right? Because T-bar ceilings will absorb noise. Carpet absolutely absorbs noise. When you have wall hangings and tapestries and furniture, like office furniture, absorbs quite a lot of noise. Even those like 5 foot high cubicle walls, they're designed for sound absorption. So you have all that going on. It's going to be quieter. It's just the nature of the world. Uh, bells. Yeah, bells have been the go-to forever. They still are popular, uh, but they are dropping in popularity, mostly because you can't get combination uh, bell strobes, right? So now you're installing more devices, so there's an added cost. Uh, Difference between a 6-inch and a 10-inch bell, well, 86 to 90 decibels. That's the rating. Of course, every 3 decibels, right? Because decibel scale is a logarithmic scale. 3 decibels is twice as loud, right? So the going from 86 to 90 decibels, that's almost 2.5 times as loud. It changes a fair bit. The 12-inch bells are pretty impressive on how loud they are. Right. So there's some Mircom 6-inch and 10-inch bells. Bells are essentially identical at this point in technology. Motorized bells are by far the most common, orders of magnitude more common than other types of bells because they are cheap and robust, very, very robust. And the bell draws 12 milliamps. Doesn't matter if it's a 6-inch or a 10-inch or a 12-inch. It's about 12 milliamps because the motor is exactly the same. It's just got a bigger gong. That's the only difference. Of course, bigger gong, it's going to affect our mounting heights because, well, math. We can mix 10-inch bells, 8-inch bells, 12-inch bells in a building. Absolutely acceptable because bells make the exact same sound, right? The actual gong has been tuned to make the exact same sound every time. We can't mix them with horns though because they sound completely different. The bells are polarity sensitive, of course. The supervisory diode is built in, it's hidden. No worries there. We can get them rated for wet locations. Uh, it's just really you just putting a gasket on and then mounting it to a weatherproof box. That's really the only change. We have to be mindful though of the size of gong that we're installing because it's going to change our mounting height. Right here it's saying that they're 20 milliamps per bell, but that's actually a little bit on the high side. I was on vacation the last few days, and so we were up in Ottawa. That was lovely. Weather was great. We went to the Nordique Spa, which is in Chelsea, over in La Belle Province de Quebec. And of course, because I'm a fire alarm nerd, I was staring at the fire alarm system in this, lovely spa. All sorts of like outside pools and hot pools and all this stuff. Very, very cool. I wasn't taking pictures though, because I wasn't going to be the creepo that was walking around taking pictures of everything everywhere. Because there's limits to even how weird I will get. And they were all, and I saw 6-inch and 10-inch bells, and they labeled very clearly on them 12 milliamps. Now they were simplex bells, but they're all about the same because they're pretty much all made in the same factory at this point. Anyways, when we're loading a circuit, just like in the rest of the electrical world, we only load up to 80%. We want to leave a little bit of space. 1.7 amps is a fairly typical circuit load. You have to check the actual control panel that you're working with. Sometimes they're limited to 1.5. They might be limited to 3. Uh, on some of the simplex power supplies, you're limited to 3 amps, but that's across 3 circuits, right? So you could have one bell circuit that's got 3 amps on it, then you can't use the other two bell circuits. So you've got to be aware of what you're working with and don't overload it. But at 12 milliamps, which is at 20 milliamps, which is a little bit high, if you've got 1.7 amps available and you only load it to 80%, that's still 68 bells. They're very efficient. That is a lot of bells. Okay, so the load is typically not an issue, and you're probably fine with 14 gauge unless you're going thousands of feet. Horns have become more popular than bells. Uh, they are very efficient, more efficient than bells. You can get them mind-bogglingly loud in a very, very small footprint. The hotel that we were staying in, uh, quite new, I think less than 5 years old. It was a Mircom system, and they had mini horns, and they had mini horn strobes, which I hadn't seen yet. Uh, and so, very, very small footprint, right? You can put it on a single gang box. Golden. So absolutely tiny. It didn't go off, so I don't know how loud it was, but definitely going to meet the requirements. You can, and we can get them in the different settings. So we can get our temporal, which is what we're really paranoid about. But we have to be very careful that we have the same sound because even different different brands of horns make different sounds. If we're looking at the same brand of horn, different models will make different sounds because there's different types of horns. So we have to make sure that we're doing the temporal pattern. No getting away from that now. Uh, I think that I think that was from like the 2002, 2006 building code, somewhere around there. I think it came in. It's been so long that I have no clue. So it's no getting around that. Of course, our audible signal devices have to be installed so they're audible throughout the floor area. Then, when we're dealing with two-stage systems, the alert signals have to be clearly audible in continuously staffed locations. And then, if there's no continuously staffed locations throughout the floor area, that's what the building code says. Authorities having jurisdiction don't really go with that. They want the alert signal to be going everywhere in the building, just in case, which makes sense. And we need to use the temporal pattern, right? So, uh, right, we're on, off, on for half-second cycles, then a second and a half in between, and then again, right? So one cycle was a full 4 seconds. Right? Also referred to as, oh, look, 1995 Ontario Building Code. Yeah, so I was way off. So yeah, so it's been code since I was 17. So yeah, it's been around for a while. Uh, sometimes it's called the 333 or the code 3 or the T3, but it is the temporal or the temporal 3 pattern. Right, so there is a typical device. These ones are pretty good, right? Goes on a 4-inch square box, but oh, look at that backplate. It's going to fit on a 2-gang box, a 4 square. I bet you it's going to fit on an octagon box. It'll fit on a single gang box, a 2-gang box, and it might even fit on a 3-inch round box. So really, if there's a box, it's going to fit, which is great. Uh, when I'm working with devices like this, usually put them on a single gang box just because it's easier to work with. And then we've got some dip switches so we can change some settings on it, right? This is a combination horn strobe, of course, because there is the strobe. And these settings are so that we can change the loudness, right? The high and low, and we can select which time we want, and it's also some of those settings that get used for synchronization because we want everything to be ringing at the same time. So depending on the configuration, you might have to do one thing versus another on it. And of course, we also are going to be using dip switches to set the brightness of the strobe, which we will talk about shortly. Right, so we can see that it pulls a little bit more, right? 37 milliamps per horn, right? So we can only fit 36 on a circuit now at 80% on the 1.7 amp circuit. That's still quite a lot. If you get if you start to put too many devices onto the circuit, you're getting into your whole eggs in one basket thing. But also, from a troubleshooting standpoint, it can be a little bit difficult if you're trying to troubleshoot and you have to go across 6 floors. It can be really annoying. So keeping it a little bit limited is probably a good thing. Right. So the nice thing with the horns, and most of the horns are like this. Uh, for the mounting and so that we can throw it on anything. Why do we go off volt DC versus VFWR? What are you talking about for VFWR? On the base. Oh, it is yeah, voltage full wave rectified. Yeah, that totally makes sense. Uh, because fire alarm systems are in volts DC. We use 24 volts DC because we run off of batteries. Uh, the ratings for the 24 volts full wave rectified, uh, that is if the horns are being used for other purposes. Because these same horns, you can get them with different covers on them and all that. So you could be using them for like industrial purposes, and uh, you could be using them for industrial purposes, and so you could have slightly different voltages. Uh, no, the panels are actually uh, they're not supplied by the batteries constantly. There was a time that they were, but it just caused a lot of trouble with the batteries. Uh, the power supply uh, provides a clean 24 volt DC uh, to the panel, and it supplies a clean 24 volt DC for charging. And then we have capacitors built in for there's about that half-second blip, uh, when we switch from the shore power to the battery power. But uh, yes, it is rectified, but that's not the only way of getting the 24 volt DC for with a full wave rectified. Right, there's other ways of doing it because if you look at the sine wave, or sorry, I guess we'll call it the sine wave, even though it's not a sine wave at this point. When we go full wave rectified, it's not a straight line, right? It still has those droops until you add in capacitors and right, the voltage stabilizers and stuff like that. Uh, right, so we look at the 24 volt DC because it's a very clean sound. If you were to take a uh, horn, put it on continuous, and put it just off of a 24 volt rectifier, you would actually hear uh, the voltage dropping on uh, on the rectification cycles. Um, it actually makes an audible difference. So we rock with 24-volt DC because it needs to be as clean as possible a voltage so that the entire firearm system will work properly. Hope that made sense. Sometimes we use chimes. I like chimes. They're very chill. But they're not very common at all. It's a very mellow tone because well, it's a chime. It's like wind chimes, but without the filling your neighbors with rage portion of it. Uh, Hospitals and nursing homes are traditionally the places that chimes are used, but very, very, very rare that they are used now because the vast majority of hospitals and nursing homes use speaker systems because they tend to be quite large buildings. But what we'll do is for the first stage, and even for the second stage, we'll use a synthetic chime tone coming out of the speakers because it does have that chill sound to it, right? It's not, screamingly angry like bells and horns. Chimes do exist. We can absolutely use chimes. We have to make sure that they are set properly, though, so that we're getting the correct sound out of it. And we can see that, milliamp draw is pretty low on chimes because they're not asking a whole bunch from it. If you look at the voltage range, right, we can get them to run at 8 to 17 and a half volts on 12-volt nominal, or 16 to 33 volts on 24-volt nominal. Uh, and that's pretty standard for all of our sound devices. They're pretty lenient on exactly what voltage you have to have, which is great so that we can use like random batteries for testing and stuff like that. Because the current is quite low on a chime, we can put crazy amounts on the, but chimes also are not as loud, so we're going to end up installing more of them. I have not yet installed a chime. I have not yet removed a chime. I've actually never seen a chime on a firearm system out in the world. Synchronization is a huge thing, and it's going to be a bigger and bigger problem. Uh, it's noticeable. Poor synchronization is very noticeable uh, when it's a when it's the temporal pattern. If it's if the bells or horns are not synchronized, it can sound almost continuous because they're just firing off at different points in that 4 second cycle. And it can be really, really annoying because you can't hear the pattern clearly. So you might not be able to tell if it's the alert or the alarm because it can be that poorly synchronized. Some of the horns on the dip switches on the back, we can make them synchronize, uh, but sometimes we have to rely on the panel to provide synchronization. Edwards is really bad at synchronization. Uh, any Edwards system that I've worked on of a reasonable size has had problems with synchronization. Uh, Simplex does a fantastic job with synchronization. I've worked on very, very large systems, 28, 30 panels all networked together, and the synchronization is bang on. Unbelievable. Mircom and Notifier are good at synchronization. I just really hate how it gets done. Mircom, I'm not a fan of the Mircom systems because it's not as efficient and clean as it could be. You have to install synchronization modules to get them to synchronize properly, which I don't get because why is that not just installed in the panel right from the factory? It doesn't make any sense. Uh, Synchronization with Miracom can be annoying to get it right and get it sorted. I've seen techs struggle for hours to get synchronization correctly. I've never seen a simplex technician do anything to get the synchronization correctly, except for turn on the checkbox to tell it to synchronize in the programming, and that's it. So I've seen it not synchronize, and the tech goes, "Oh, I forgot to synchronize it." Just hits the check and then re-downloads, and off you go. But has to be synchronized. Now, it doesn't have to be synchronized across an entire building, right? That's just not worth the effort. Synchronization, we're talking about when it's audible or visual from any single location. So wherever you stand, it's clear. That's all that matters for synchronization. Mounting heights. Mounting heights, very important because, well, that's what we do. Uh, Mounting heights have changed over the years. Even since I've been doing fire alarm, mounting heights have changed. We've increased the minimum height of signaling devices since I started in the trade. It's now a minimum of 2,300 to the top of the device. We're getting taller, and you don't want to get a horn to the ear. It is very unpleasant. So minimum of 2,300 to the top. Except, of course, if you have integral silencing for in-suite, right? If in the in-suite silencing, if it's built into the horn, you have to put it down at 1,100, right? Same size, same height as the pull station, which is one of the reasons that they've gotten away from it because it's just, you know, in range of a lot of damage, and especially if the horn is mounted where you happen to put your couch, you're going to take it to the ear, and it's terrible. So minimum of 2,300 above finished floor level. Very important. Also important, minimum of 150 millimeters below the ceiling to the top of the device. Because if it's too close to the ceiling, when you get into that, top 6 inches, you're gonna get weird echoes coming off of uh, the ceiling as the sound waves reflect off the ceiling, and it can affect your synchronization and your just ability to distinguish exactly what noise is coming out. So we have to be very mindful of that mounting height, right? If we go back a little bit, right, this horn gets mounted on a 4-inch square box. Great. So we make sure the top of that 4-inch square box is uh, at least 150 millimeters down from the ceiling, and we're going to be good because that's if we put it exactly 150 millimeters down, that means that we're going to put it 27/64 of an inch too high, right? So pretty close enough. If you're getting that close, there's only so much you can do. But if we go back even farther, that one, oh, that is absolutely mounted at the wrong height, isn't it? Right? Because it's approximately 0 millimeters from the ceiling. You're going to get weird reverberations from that one. But if we continue to go back, bells. That 6-inch bell gets mounted on a 4-inch box. So the top of the device is 1 inch higher than the top of the box. We've got to make sure that we allow for that. And that's the 6-inch bell. If we go with the 10 and the 12-inch bells, we have to be considerably lower because the bottom of a 6-inch bell is the same distance from the center of the box than the bottom of the 10-inch bell because they move the center line of the bell up because the back portion of a 6-inch and a 10-inch bell, this part is identical. There's just an additional bracket for the mounting. So if we have 10-inch bells, the boxes have to be mounted lower. So we have to be very careful with our mounting heights so that we don't have things mounted too high or too low. We absolutely want to know what type of device and what size of device we're installing before we add the boxes to the wall, right? So if we have two signal circuits, we might have to add sync modules. The sync modules might go in the panel. If you have a decent quality panel, like a simplex panel, it's built into the system. Or we might have to put it in a box. It might be a box, a four square box that gets installed just outside of the panel, which really, really annoys me because you just can't get a clean install when you're adding all this random crap that shouldn't have to be there. But we might have to do that. We might have to put in synchronization. Barrier-free means of access, that applies to our notification devices. When we're talking about the audible device silence buttons, right, has to be between 900 and 1100. So 1 meter to center, we're good. 1100 to center, we're still good. I tend to go 1100 to center with these on the rare occasions that they get installed. That way they're the same height as the pull stations. Of course, for anything that has to be barrier free, we need to make sure that we have enough space to get a wheelchair right up to it. So we can't put it tight into the corner or anything like that. So we have to be mindful of that. Luckily, you're almost never going to see these as being installed new unless you're doing renovations to an existing building and these exist everywhere else in the building. You're going to be installing them again. Back to our audibility. Of course, we have to maintain our audibility. On our suite silencing, we can silence up to 10 minutes. We have to make sure that it's installed to achieve audibility requirements inside all the rooms, minimum 75 decibels in the sleeping rooms. And we have to install it so that we maintain our barrier-free path of travel. So we have to be mindful of that. Right? And we install them as a Class A. Sometimes our suite silence devices uh, have to silence more than one device, and so we'll have to do some additional wiring. It could be a little bit complicated. I haven't had to do this yet. The only times I've worked with suite silence devices, it's when it's been the only horn in the apartment, so it hasn't been an issue whatsoever. And you don't have to pull 24 volt to run the suite silence because it was just built into the unit. But if you have multiple uh, signaling devices in a unit, then you are likely going to have to pull 24 volt to run the suite silencers properly and control all the uh, signaling devices in the unit. So you're going to have to make sure that you're aware of that before you start to wire all your devices. You don't want to have to squeeze more wire in and possibly rewire your circuits inside the suites when it's already painted. Like that's going to suck. Visual signal devices. Our visuals, of course, produce light and light patterns, also light patterns in the light. Right? That's all they do. We can get combinations. On the left, that is a combination horn strobe. On the right, it is a strobe only. Right? We can tell because there's no vents to let the noise out on this one here. But they've made them look pretty much the same, so aesthetically, it's pretty good. But we're not going to worry about the audibility portion because we just finished talking about that. We're just going to talk about the visual portion, right? Our strobe lights and our visible signal devices. Strobes, that's what we're going to see the vast majority of the time. synchronized flashes to alert hearing impaired occupants to evacuate premises. And of course, in this day and age, hearing impaired occupants also includes like everyone from 12 to 25 because they're always wearing headphones. Typically, we install them on walls or ceilings. I have not seen any installed on the floor yet, but I'm sure someone's had to do it somewhere. And they have a specified candela rating. Of course, the higher the candela, the larger its coverage area, right? The brighter, the farther. Makes sense. That's our strobe lights. Then we have our visible signal devices. Uh, Lights to notify occupants of a building to an emergency situation in a direct or indirect manner. So we could have exit signs that only light up in certain circumstances, right? For alternate exits and stuff like that. We could have fire do not enter signs to let us know don't go into this building because there's a fire. Uh, there's also scrolling signs that get installed on occasion to notify people of various fire emergencies. But strobes are by far the most common, and we have to install them in a lot of places these days. You know, we can get them manufactured for interior and exterior use. Uh, Xenon flash tube ones are pretty rare these days on new installation, but there's a bajillion of them out there. But you can mix and match. So long as they are compatible, you can even put them on the same circuit. They look the same when you have them blink, so that's not an issue. LEDs, great for lower power consumption. They are DC. They need to have a constant voltage source. They have to be on a rated circuit. Sometimes they have to go on their own circuit. Sometimes we have to use a separate horn circuit and a separate strobe circuit. It depends on the design of the panel and the design of the appliances themselves. It's very rare these days. The combination horn strobes, typically we just end up one pair of wires in and out on the circuit. Speaker strobes, of course, that's going to be two different circuits because speakers operate completely differently from bells and horns. Strobes are polarity sensitive. They have built-in diodes, and they are designed for specific applications. They are either ceiling mount or wall mount. There's only a couple of them out there that you can mount on the wall or the ceiling. It's very, very rare. And that is because of the actual optics. The lenses are designed to throw the light in specific directions. So the lens of a ceiling mount and a wall mount is going to be completely different. Right? The device might look nearly identical, but it's going to be completely different uh, lens and reflector design. The higher the candela rating, the more current it's going to draw. Right, so if you look at this here, 15 candela on a wall mount, 25 milliamps, 185 candela, 179 milliamp. Pretty big change. So we have to make sure that we calculate for all that to make sure that we bring enough circuits with large enough wire. Right? I've done systems where we can put a maximum of 10 devices on a circuit because of the intensity that we had to run at. We were running at 130 candela, and the most of the runs were about 1,000 feet because it was an Amazon building, big building. So we were able to put 9 or 10 on a circuit out in the main warehouse area. In the office areas and stuff, it was a much lower candela rating. We could put more on a circuit, but we're looking at 9 or 10 strobes on a circuit with 12 gauge wire. It was insane. Okay, so that can be a huge issue. We have to be very careful with that. Right, candela, of course, is how bright it is in metric. Um, the luminous intensity has to be not less than 15 candela. That's the minimum rating. 15 candela, it's tolerable for the vast majority of rooms. It's bright enough, but it's not going to be super painful. But you can get pretty bright. The minimum candela rating for smoke alarms or uh, so is it uh, smoke detectors being used as smoke alarms in sleeping rooms is 175 candela, I believe. Like it is aggressively bright. Uh, you can see them with your eyes closed. It's absolutely crazy. This is pretty generous, this one here. 30 candelas at 30 milliamps per strobe, 34 strobes per circuit. That's rarely will you get to more than that. And you're probably using 16 gauge or 14 gauge because the voltage drop becomes more of an issue. Most of the manufacturers have calculators. Either you might be able to download them or it might be web-based, uh, based on the specific parameters of their devices. And so you can just, I'm using this model. I have to go this distance. How many can I put on the circuit with what size of wire? That stuff is out there. Uh, it might be an old school table. You might have to do the math yourself. Depends on uh, the manufacturer. Synchronization becomes crucially important with strobes. Uh, the strobe pattern has been designed to not cause seizures. And that's a complaint you get a lot when you're doing retrofits and building. Oh, it's going to cause seizures. No, it doesn't. If the fire alarm goes off and someone has a seizure because of the strobes, it means they were about to have a seizure anyways, and it's coincidental. It is absolutely not an issue. Uh, so long as they are synchronized properly. If they are out of sync, well, now they're not blinking at the same pattern, and it could cause seizures. So synchronization is crucially important, and that's where I see Edwards really struggle in large open areas. Uh, when you can stand in one spot and you can see like 25 strobes down the line, yeah, they are not in sync. It's always a struggle. But I've seen Mircom systems and notifier systems and simplex systems in that similar applications and all blinking at the same rate. So Edwards just seems to struggle with that. So synchronization crucially important. But again, that's for whatever you can see from one specific point. We, well, most of us can't see through walls. I don't know if any of you are superheroes. Uh, So if it's on the other side of a wall, it's not an issue. It's all the strobes that you can see from any given point. We have to have 100% audibility in a building, right? We have to meet 65 decibels everywhere. At a minimum, 75 decibels in sleeping rooms. Strobes is a little bit different. Right? We have to augment our visual. So we have to augment our audible with visual when we're in high noise areas, people are wearing hearing protection, audiometric booths, and all that. But in addition to that, we have to add visual signal devices in buildings or portions of buildings intended for primarily by persons with hearing impairment. So in Brantford, there is a school for the deaf and hard of hearing. There's strobes everywhere. Any public corridor serving a group A, B, C, D, or E occupancy. So everything except for industrial. If it's a public corridor, it has to have strobes. Then again, in a corridor used by the public and in a floor area are part of a floor area where the public may congregate in a group A occupancy. Group A occupancy, assembly occupancy. So you think about a banquet hall. In the public corridors, we're going to have strobes. In the banquet hall itself, where we're sitting down to an awards dinner or uh, a wedding or anything like that, that's a floor area or part of a floor area where the public may congregate. They're getting strobes. At least 10% of the suites of a hotel or motel, so that if uh, hearing impaired people are renting the room, they can get a room that is suitable for them. And then in the living space in a suite of residential occupancy in a Group C major occupancy apartment building. So Group C, right, residential occupancies in the living space. Living room gets a strobe. Visual signals, visual signal devices are permitted to be installed in lieu of audible signal devices in certain locations. In special care and treatment facilities, we can use visual signal devices in certain locations. Uh, Operating rooms. Uh, at the Hamilton General Hospital, I did the fire alarm there. There is there's speakers everywhere in that building, right? There's approximately 11 bajillion speakers in the building. There are zero speakers in the operating rooms, not a one. There's speakers in the hallways around the operating rooms, but not in the operating rooms, which makes sense, right? Because if you're the chief of complicated surgery and you're trying to, reassemble someone's heart or something like that, you don't want to get startled by the fire alarm. You especially don't want to get startled by someone paging to move a car, right? So we're not going to put audible signal devices in there. Right? We are allowed to not do that. Of course, we have to get permission from the authority having jurisdiction. Otherwise, they're just not going to approve the project, but it is totally doable. At the same time, we're not going to put a strobe into an operating room because we don't want that bright flashing light to startle the surgeons. That's a bad idea. This is where I've installed scrolling signs. We installed the scrolling signs directly above the door to the operating room, inside the operating room, because the surgeons do not face the door, right? So it won't even be in their, peripheral vision. They're not going to see it at all. The other staff in the room are going to see it, and it's going to tell them, oh, it's a first stage, it's a second stage, it's in this area, all that stuff. You can do some pretty fancy stuff with it, right? So this is where we're using a visual signal devices, not just a strobe, right? So there are places that we can do that. Same thing with recovery rooms, delivery room, ICUs, critical care units. One of the reasons being, so the operating rooms, we don't want to panic the surgeons, but other places where you just can't move people in an emergency, right? You can move them if you have to, but if you don't want to, you don't want to. Like the ICU, if you evacuate an ICU, way too many of the patients will not survive that transfer. So we want to avoid doing that. But we don't want to stress them out either, right? Delivery rooms, mom's about to give birth. She's been in labor for 32 hours, and the twins still haven't come. You know, uh, Patience is at a minimum. We don't want the fire alarm going off and freaking them out. So we can put in visual signaling devices instead, because the it's not you know the parent to be's responsibility to deal with a fire situation. In that At that point, it is the staff's responsibility. Right, so impractical to move the patients. Of course, if we're going to do that, we have to have additional considerations made, right? We need to make sure there's a separate mechanical air supply, so we're not going to get filled with smoke, all sorts of additional requirements, but it is an option. Now, I've done work in recovery rooms, delivery rooms, ICUs, critical care units, and I've just put in speakers, right? Put in the normal audible signal devices like the rest of the building. They haven't required it. It was just the operating rooms that we had to do something different for that particular building. Different buildings will have different opinions on that subject. Back to our visual signal devices like strobes. We don't have to put them in classrooms. Right? If we've got a school, we're going to have strobes in the hallways. We don't have to put them in the classroom. Now, if it's a school for the hearing impaired, we're going to want to put them in the classrooms, but we're not required to. Uh, we also don't need to put them in Group B Division 3 occupancies that claim to contain sleeping accommodation for not more than 10 persons, and not more than 6 occupants require assistance in evacuation in case of an emergency. So a very, very small retirement home, group home, or anything like that, we don't necessarily need to put our strobes in. Usually you're going to see them, but not absolutely required. Anywhere that we have to put in visual signal devices, we have to install them so you can see them. Makes sense. So no matter where you are in the floor area or portion of it where they're installed, even if you're standing right in the corner of the room, you have to be visible, line of sight, to at least one strobe, which totally makes sense. Right? So we put our strobes in when we're high ambient noise over 87 decibels, or occupants of the floor area use hearing protective devices, audiometric are in audiometric booths or sound insulated enclosures, and then uh, public corridors in A, B, C, D, and E occupancies, uh, floor areas or parts of floor areas where the public may congregate in a group A occupancy, right? We have all these requirements. 10% of the suites of a hotel or motel, public washrooms for public use. Any washroom that is intended for public use has to have strobes, and the living space in a suite of residential occupancy in a group C major occupancy apartment building. Right, 32419 alert and alarm signals. Good one to be aware of. It's a pretty important one. So our strobes, right, which is what we're talking about, not less than 15 candela. Right, there are some out there that can be set at 5 candela. That's because they're also being used in the States, but that's pretty rare. Usually you see a minimum of 15 candela. Synchronized flashing, absolutely important, not random flashing. So for everything that's in the same field of view. And then mounting height, minimum of 2,000 meters, 2,000 millimeters above floor, maximum of 2,400 above finished floor. We don't want it right into the eyeballs of people, but we want it pretty close to their line of sight so that it's going to be as visible as possible. Sometimes we're going to be mounting them a little bit higher. Good engineering comes into that. But unless the engineer has specified that we have to put it at a different height, we're going to mount it between 2,000 and 2,400. If you recall, 2,300 was our minimum mounting height for audible devices. So if we mount them at 2,300, and it's a combination device, we're good. We meet all the requirements. That is, of course, for wall-mounted. Ceiling-mounted devices can be installed higher than 2 meters above the floor because they get mounted on the ceiling. Then we have to be careful about where we mount them on the wall because we need to make sure that the entire floor area is located within the coverage area of at least one strobe light. And there are rated limits for how far that light is going to travel. And of course, we have a table for that, right? If we have a 12 by 12 meter room, if we're going to put one light in, it needs to be set at 60 candela. If we're going to put two lights in, we're going to rate them for 30 candela. If we have a 6 by 6 meter room, we're going to put a 15 candela in for one. We cannot put two in that room. It'll be too bright. It'll be too much. Right. So it just depends on the intensity. I've never seen anything that does above 177 candela. They exist, right? I've seen lights more intense than that. I've uh I've done I've done some stuff in a uh, automotive paint laboratory, and they had an indoor sun. Yeah, it looked like a cartoon light bulb. It was ridiculous. The light bulb was like 4 feet around or something like that. Massive. It had the same intensity as noon in Arizona in July. Like it was just mind-bogglingly intense. But it also was not a strobe. It just the light was water cooled, so it wouldn't overheat. It was absolutely ridiculous. Right. So depending on the size of the room, it's going to change the number of lights that we're going to have so that we have the proper coverage. Right? We could have one light in the room, we could have two, we could have four, we could have more. It depends on what we're dealing with. So the strobes, and this is out of Appendix A, informative, right? Just more information of CSAS 524. Most fire alarm strobes flash at a 2 hertz rate, that's 2 per second, which is completely safe. But like I mentioned, if they're in the same area and they're not synchronized, that frequency is going to multiply. So we have to synchronize them, right? If you get 4 or more cycles per second, 4 or more hertz, it could be an issue, right? If we keep it 2 hertz or lower, we're going to be fine. So synchronization, absolutely crucial. Our layout, if it's a square room, relatively small, is pretty easy. If it's a rectangular room, not necessarily as easy. We have to just break it up into separate chunks, right? We have this L-shaped room we end up using 4 strobes, right? And if you look in the bottom part of the L there, we've got two 15 candela. If you recall, a 6 meter wide room, we couldn't use 30 candela. It was too bright, right? Which is why we end up with two in this particular area, right? So we've got to be careful of what we're installing and where we are installing them. One of the areas being in larger rooms, the installation of the strobes can be counterintuitive. If we think about a large, pretty square room like a school gymnasium, 4 strobes, let's put one centered in each wall. That is absolutely incorrect because the corners aren't going to be properly covered. 4 strobes at 30 candela is not going to work for this room layout because we can only throw light a certain distance. And we uh, we did see that in a table. I'm going to go back for a while there. This one here. Right, there's a maximum width that we can get to uh, because we don't throw as much light like at 90 degrees as we do, straight out. So we have to offset them. If we treat that large room as 4 squares and we center each one on a wall in the 4 squares, we're going to get proper coverage. So we have to be mindful of that because that's something that during verification we check carefully. Can we see the strobes from everywhere? And is it sufficiently bright from everywhere? So that can be an issue. When we're dealing with ceiling mounted strobes, they can only be put so high. Uh, Anecdotally, at least, ceiling mounted strobes are not as effective as wall mounted strobes. They tend to be more easy to ignore because everyone is walking with their hood up, hat down, staring at their phone, and they just don't notice the strobes. So we've got a maximum height of 9 meters above the floor for ceiling mounted strobes. Ceiling mounted strobes are great because they're up and out of the way, but generally speaking, it can be a bit of an issue. Uh, and often we have to use higher candela for the same areas if we are ceiling mounting them because we do not have the actual lens in line of sight. So we're relying a lot more on reflected light. So that can be an issue. If we can't put that light dead center, then we have to make sure that we're still getting enough light in the far corner. Just like when we talked about initiating device coverage, when we were looking at wall-mounted strobes, we have to make sure that we cover all portions of the room. Then in hallways, we have to be more careful as well because hallways tend to be on the narrow side, right? And we we refer to hallways anytime at 6 meters or less in width. Anything wider than that is really a room, not a hallway. And so the number of strobes that we put in, of course, is a factor of the length of the hallway. And we almost always use 15 candela because they get mounted on the walls. And if you have it set too bright, it can just be too intense in certain areas. So we're better to have it at a lower candela and not spread out quite as far. But we can still go quite a distance. If we look at this E-shaped hallway, right, it's 30 meters long on the long portion, and then we've got the legs of the E's. We've got one right at the end, and then we've got three on the long portion, right, shining down, and in the middle, right. It's a pretty decent layout. We're going to have full coverage because there's no dead spots. Like light doesn't bend around corners. We have to be a maximum of 4.6 meters from the edge of the end of the hallway to the first device. That way we can get all the way to the end. And when we have weird bump outs like this, we have to make sure that we have coverage. By putting it right in here, we can get coverage. If we'd put this one on this side, we would still be getting our coverage. But we have to make sure that anytime we have some sort of obstruction from a corner affecting line of sight, we have to make sure that we allow for that. And broadly similar when we're talking ceiling mounted in hallways. Anytime we have doors or changes of elevation, we have to make sure that we allow for that as well, because we have to maintain that line of sight. And polarity matters. We're not going to talk about addressable devices because addressable strobes exist, addressable horns exist, addressable speakers exist. Uh, they function ultimately the same. How we get them to function like that is different. The number that we have to install, the location that we install them is exactly the same. It's just how they get uh, wired and configured is different. So we'll be talking about that when we get to level 4. Other types of visual signal devices, the big one is fire do not enter signs. They're not used a whole bunch, and they're really not that effective. People just ignore them. Uh, but we do have to put them in because we're going to assume that people actually pay attention to signs. I know, I'm pretty funny. Uh, our fire do not enter signs are connected to the fire alarm system. They have to be on electrically supervised circuits. We used to put them on just any old power and control them through the fire alarm panel. We're not allowed to do that anymore. They have to be on fire alarm notification appliance circuits because they are part of the fire alarm system now. They cannot be affected by signal silence. The interesting thing with signal silence, when you silence a fire alarm, the horns stop making noise, the strobes keep going, and the fire do not enter signs keep going. They keep, uh, I think they just stay on solid. I don't think they blink. Um, I've installed a lot of them. I don't remember right now, but they're not affected. They are still functional. And we use them in places like this. When we have interconnected vestibules or walkways or tunnels or bridges from one building to another, we need to know if the fire alarm is active in the other building. Because if the fire alarm is active in building B, then we don't want to be walking from building A into building B. That's just a bad idea. So we put fire do not enter signs in. The fire do not enter sign that is in building A that we see as we walk towards building B is controlled by the building B fire alarm panel because that's the one that knows it's an alarm. And so they get put on the opposite sides of the vestibule. It's one of the few times that we actually have parts of the fire alarm system leaving the building that is not going off to monitoring. The other thing that we might have, I have not yet seen these out. Well, I've seen them out in the world, but I have not yet installed any of them. Directional signs for evacuation. The arrows on the running man or the entire running man sign might illuminate only under certain conditions, right? When it's alternate exits. If we're using these, and it might just be the arrow portion that lights up, but uh, any of this that we are, any of these directional signs that we are connecting to the fire alarm system are going to be powered by the fire alarm system. So they're going to go on a notification appliance circuit. They are not going to go on the same circuit as horns or strobes. They're going to go on their own circuits. They're going to be supervised. And they're going to be not affected by signal silence. Right. And here is where we might be seeing them. If the egress is actually being affected by the fire emergency, we might turn that one off and turn on other ones to help direct people out. Again, I've never seen these be installed. I think I've seen them in the world, but I can't say for sure because I've never seen them activated. Uh, we're talking about a very, very complex system if we are adding this stuff in. But there are rules for it. And the control mechanisms in the control unit to get all this stuff working properly, that's definitely going to be a lot of programming to get it all work the way that we want it. So our combination devices, this is what we're seeing most of the time these days because, well, it's faster and cheaper. The interesting thing with combination horn strobes, two wires go in, two wires go out. Uh, Fire alarm goes off. We get the tempo. If it's a single stage, we get the temporal pattern, and we get the blinking of the strobe. When you hit silence, the horn stops working, but the strobe keeps working, even though it's on the same pairs of wire. Some sort of magical thing is happening in there. It's sending some sort of a digital signal on top of the 24 volts to tell things to turn on and turn off. Very, very cool. That's how we're seeing it most of the time these days. We can see them wired separately as well. Very easy to tell if you look at the back and it tells you, these positive and negatives for the horn, these positive and negatives for the strobe. Yeah, it's being hooked up separately. So we need to bring two circuits to it. And you need to bring the strobe circuit and the horn circuit. I have not encountered one of these types of devices in a number of years now. I'm always seeing it like this combination devices. It's using the magic of computers or whatever it is, uh, so that our horns and strobes are on the same wires. Right, so we're seeing the top, not the bottom, but those systems still exist. You might come across them either in replacing a existing system, or you might be doing alterations to a system. The difficult part, of course, is getting the mounting correct, right? If we have a combination horn strobe, we have to make sure that we meet the mounting requirements for both of them or get absolutely as close as we can. We can also cover them for protection, so long as it's a suitable and rated cover. The cage covers are great because, well, they're not obscuring the strobe and they're also not obscuring the noise. So we see the bubble cover on the bottom. It's got all those slits in it so the noise can get out. But if you read the manufacturer's instructions, it probably gives you a decibel reduction as well, so that you're going to have to factor that in. So you've got to be careful with that to make sure that when you add these covers, you're still going to meet your audibility requirements. And that is signaling devices. Next up, we're going to talk about the assignment, but we're going to take a little break ski first. It is currently 8:19 p.m. So we're going to start up again at 8:30. It's not going to take us all that long to cover the assignment, but we definitely want that done tonight. So we're going to stop right here and we're going to start up again at 8:30. So I'll talk to you guys in 11 minutes. And we're back. The print assignment. We have three sections of the print assignment. You don't have to complete this all at once, but you obviously have to complete all of it. I'm going to, once we're done talking about this tonight, let's be honest, I probably won't send it out till tomorrow. I'm going to be sending you a soft copy of the assignment. So if you're relatively computer savvy, by all means, fill it out electronically, send it back to me as a PDF. Not a problem. If you're not technologically savvy, fill it all out by hand, take pictures of it with your phone, convert it to PDF, and send it to me electronically. Either way, doesn't matter. Make sure when you send it, you have your name on it so that I know whose it is. I am not a mind reader, not even close. I can't even read my own mind. So, we've got some drawings that we're referencing, and we have some stuff that we have to do on the drawings. So part one is code references. Right, so here is the code references, and we can see that the first part has already been filled in for us as a little bit of a helping hand. If we go to our drawings in room 411, there is that device. And we know what that device is because we can look at the legend. And so I want to know all about that device. According to the legend, that is a 57 degrees Celsius rate of rise fixed temperature heat detector. Right? It does the rate of rise and it does the fixed temperature. And I know that it's on fire zone 4. Great. And I know that QLC S524 talks about the installation of those in 8.2.3.1. So those have already been filled out for us to give us a little bit of a helping hand. But I can see that there's nothing under the Ontario Building Code column. The Ontario Building Code is going to tell us why that device has to be there. So that needs to get filled out, right? 3.2.4.9 or 3.2.4.3.2.a, whatever it's going to be. Ontario Electrical Safety Code, yeah, there's requirements all about that, all in section 32. Right, so I'm not hugely excited about Ontario Electrical Safety Code because, well, we know the code. Then if we look off to the right, Ontario Fire Code. Yeah, I don't care about that at all. This is a new building, right? This building is being built brand new. Ontario Fire Code does not apply. So nope, 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 nope. I don't care about the Ontario Fire Code. We can ignore that column completely. Okay, so there's 6 columns. We're only doing 5. Oh, look at that. Right? We've gotten rid of 1/6 of the work already. We're almost done. So we have all these devices shown. I want to know what zone type and what zone number they are. I want to know what type of device it is. And I really care about the Ontario Building Code and S524. Right, those are the 2 columns that I'm really excited about. If you want to put in nothing for the Ontario Electrical Safety Code, yeah, I'm fine with that too. We all know the code. We know the code, and we know that we know the code because, well, we're licensed electricians. But we don't know about building code and S524 so much. That's why we're here learning. So those are the 2 columns that I'm really excited about. And we have 2 pages of that. Here's another little hinty hint for you. Right? In the mechanical room, we've got 2 of those symbols. That's an ionization type duct smoke detector. There's 2 of them, of course, Fire Zone 7 and Fire Zone 8. And they are ionization in duct smoke detectors. And we have to have them because of 32413 sub-rule 1, which says that an air handling unit that serves more than one floor has to have duct smoke detection. Right? And this air handling unit serves more than one floor. So there we go. And that is part one of the assignment. Part two of the assignment, let's my computer's decided that it's going to be run very slow. It's decided that it's maxing out on its brain power, and it's having a few issues. It's a little upset with me, but I will get there. So I just try to flip through here to get to the part two of the assignment. Right. So part two of the assignment is the flagged conduits. Right. And we have 16 flagged conduits. So let's flip over to the drawing itself and look at the flagged conduits. See, it's taking forever just to load what's on the page here. Okay, so here is the fourth floor of the building. We do not have the complete building. We only have the fourth floor and the riser diagram. I think this was the riser diagram. Nope. Must be this one's the riser diagram. Come on, you can do it. There's the riser diagram. Okay, so the riser diagram, so we can see flags 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the riser diagram, and then 11 through 16 are on the floor plan. And so what we're looking to do is at that flag, and so we're going to zoom into flag number 1. I want to know what zones are at that point and the number of conductors in that conduit. So we're going to take our imaginary Mr. Bandsaw and we're going to slice through that conduit, and what is going to be in there? Right. So uh, I can see that my fire alarm control panel is way down on the ground floor, maybe in the basement. Definitely some brain power issues there. So there's my main fire alarm control panel right down here on the first floor. Right, so I've got a riser pipe going up and then going over and up and into here. Uh, we have on our riser pipes, we've got a separate conduit for each wiring type, right? Our fire zones and our audible zones and our visual zones are all on in different pipes. Our ancillary relays are in a different pipe. In the real world, we wouldn't be doing that. We'd be running one pipe up for everything, or maybe two pipes. We'd be combining things together for convenience and cost effectiveness. But since we're here in the paper world, let's split them up so it's easier to tell. So we come from the fire zone junction box on the fourth floor over to this point here. So if we take Mr. Bandsaw and slice into the pipe here, what am I going to see? Well, I downstream I have fire zone 1 and I have fire zone 4 and I have fire zone 9 and I have fire zone 7 and I have fire zone 8 and fire zone 10 and fire zone 5. So I've got 1, 4, 5, 7, 8, 9, and 10 at that point. So that's the number of fire zones that I have. So I know 7 fire zones, I'm going to have a minimum of 14 conductors. But I could be going out and back. So I have to look at the end of lines. Fire zone 10 is right here. There's the end of the line. So I've only got 2 wires coming through here for fire zone 10. Fire zone 4, oh, there's the end of the line. Fire zone 1, there's the end of the line. Fire zone 9, fire zone 8, fire zone 5. All 7 of these fire zones, the end of line is to the left of the flag. So I know that I only have 2 wires each. But if we were to look over here, if I was going to cut that conduit right there, if I was going to have a flag there, uh, the only conductors I have running through this conduit is for fire zone 4. Because I have fire zone 4 on this side, fire zone 4 on this side. So I only have fire zone 4, but I would have 4 wires in there because I've got fire zone 4 would be coming through, picking up these devices. It would go through here, pick up these devices, but then it has to go back out and all the way around here, back down here, and over here, and over here to get to the end of the line. So I would have just fire zone 4, but I would have 4 conductors. So that's how the flags work. At this point in time, how many zones are going through that conduit? What are the zones? And how many conductors I have. So what zones do I have going through and how many conductors? And we're going to do that for all 16. That is part 2. That's the flagged conduits. Part 3 is the missing devices. There are a lot of missing devices, a very large number of missing devices. I believe your assignment says that there are 6 missing devices. There are way more than 6 missing devices. There's way more than 8 missing devices. But that is the benchmark. We're going for 8 missing devices. You need to find me 8 missing devices on the drawing. I want to know what device type and symbol it is. I want to know where it is. And I want to know what zone it is. And I want to know why it has to be there. And of course, we need to put on the drawing and add it into the pipe run. That's important to do so that we know that we've all got them all. We can see it visually. But also, because there's missing devices, that might change your flags. You might be adding some wires into a conduit. So you definitely want to do part missing devices before you go to your flags. Right? Do your missing devices before you do your flag, because it could change the math slightly. Right, so we have this, practice one here, and this is one of the 8 that is missing. We have a fixed temp heat detector with that symbol. It's in room 417, the janitor's closet, fire zone 4. Right, and there it is right there. Right, so that is missing on our drawing. Right? We've got a device missing. and we're going to use a fixed heat detector in there. You will recall from last week, the week before, uh, we need to put a fire detector in any janitor's closet, right? It's one of the required devices, and that is 324.11.2C of the Ontario Building Code. Right? All these references are in our course books. And so it goes in there, and right, we're just drawing it off of the superintendent's office. You don't have to draw it off there. You can draw it off wherever you want, which is why I'm saying that depending on what missing devices there are and where you choose to add them in, it may affect your zone counts and your conductor counts on your flagged devices. I could absolutely wire this right from, I could add a box here, or I could bring it off of this box here. It depends on what I feel like drawing in. Both of those would be absolutely correct. Uh, so we have to make sure that we show that. If I showed it coming off of the bell, that would be incorrect because the bell is on a different circuit. Now that entire area is fire zone 4. There's no fire separation or anything. So again, that fixed heat in the janitor's closet ends up on fire zone 4. And we're using a fixed heat instead of a rate of rise because janitor's closets and things like that are prone to false alarms if you use fixed heat. Because if you dump a bucket of hot water into the slop sink, you could trigger under rate of rise. So that is the third part. But before we get too crazy about the three parts and get started on it, we're going to have to look at the drawing as a whole because, well, this building is a little bit on the weird side. So let's start by looking at the riser diagram, right? If we look in here on the first floor, we can see that it's not complete. Same with the second floor and the third floor. We don't have nearly as much information as we have on the fourth floor. We're seeing typical, right? We're seeing there's devices, it's typical, and it goes back to fire zone 11. So this pipe goes back to the junction box there. It's just not even shown in. This to visual zone junction box, typical, right? And this one here, right? So we need to be aware of that. It's typical. We're not seeing everything. We only have parts of the drawing. So we have to be mindful of that. There's things missing because, looks like we're not even doing we don't even have the contract for the first, second, and third floor. We're just doing the fourth floor. So that's fine. We'll concentrate on the fourth floor. If we look at the fourth floor, the building is a little bit odd, right? If it's an office building, obviously, look, office, 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 office. It's an office building, right? Which would make it a group D major occupancy, business and personal services. But then if we look right here, room 420, CEO's apartment. The CEO has decided that he wants to live in this building as well, or maybe spend the occasional night here or whatever. Definitely getting a little bit on the little high on the weird, creepy scale. But CEO can do what a CEO wants so long as it's legal. Uh, so it's the CEO's apartment. It's an apartment. It's a place to sleep. This makes it a residential occupancy, right? So we have a dual use building. It is a residential occupancy and business and personal services. So that's a group C occupancy and a group D occupancy. So we have to conform to the requirements for both group C and group D major occupancies. That's going to determine where we have to put our devices, what devices are required. For example, in a group D major occupancy, we don't need to have heat detectors in offices. That's not a requirement. We need to have them in storage rooms, right? This storage room 414A has to have a heat detector in it, a fire detector, according to the requirements for Group D major occupancies, but not this office room 411. However, in a Group C major occupancies, all rooms not within the actual apartment or suites of residential occupancy have to have fire detectors in them. And this building is unsprinklered, so we have to put a heat detector in, which is why we have so many devices, because it is a Group C and Group D major occupancy. Right, so that is one part of a little bit weird in this building. Right. And then if we keep looking at the CEO's apartment, right, we can see that the devices are an IA, right? The I portion, if we look at the legend here, it's a smoke ionization type smoke detector. Great. But then, if it ever loads, we can see that A, the IA is a ionization smoke alarm, not a smoke detector. To make a smoke detector into a smoke alarm, we have to put the sounder bases in. And we talked about that when we were talking about our initiating device, the sounder bases. And that's our interconnection. Right? If this device here activates, then all of these interconnected devices are going to activate just like smoke alarms. But because it's a sounder base, it's also going to be sending the signal back to the main fire alarm control panel and setting off the entire building. So the CEO will know that the alarm is coming from inside his apartment, not just somewhere else in the building. Where it is doing dual duty, being a smoke alarm and a smoke detector at the same time. So that is what we have there. One of the one of the things that I like to do when I start any fire alarm project, right, you get handed drawings like this, you gotta start by familiarizing yourself with the building. And so one of the things I do is I draw in all the fire separations. And because I'm a creature of tradition and I've been doing it like this forever, I use pink for fire separations. I'm not using pink for other colors, for other things. I like to use full color. I draw in my fire separations. The fire separations, we can usually tell because it's a thicker wall, or there might be an entire separate drawing of fire separations. This building is pretty simple, and so it's pretty easy to tell. A stairwell, let me make that whiter and more opaque. There we go. A stairwell has a fire separation. We know that. And since it has a fire separation, it gets its own zone. Right? So I draw in the fire separations around the stairwells. Right? Because we can look in the building code at uh, the zoning requirements. Right? We talked about that when we were talking about our initiating devices on what things get different zones. And so we know that shafts get their own zones. So that's stairwells and elevators. And these elevators, we've got two elevators, but they have separate shafts. So great. So that's fire zoning done. Electrical rooms, mechanical rooms, things like that, don't get their own fire zone. They only have a 1 hour fire separation around them, not a 2 hour fire separation. So they are zoned the same. And we can see that if we zoom into the mechanical room. Oh, they gave this one its own fire zone. Okay, right? Because I've got fire zone 5 here, fire zone 4. So this one is out of the ordinary. This is not a common occurrence for a mechanical room to have its own fire zone. But this building happens to have it. The electrical room doesn't have its own fire zone though. It does. It's got a 1 hour fire separation, not a 2 hour fire separation, because it's just an electrical room. It's got some panels in it. It's not like it's a hydro vault and it's got the high voltage because those get their own fire separation. Okay, so that is actually the extent of the fire separations in this building. So I like to draw them in like that because it just makes it easier for me to know, figure out exactly what's going on. And it's a good place to start, especially when you're looking for missing devices. It draws your eyes to the more special areas. So there is a total of 8. Well, there's more than 8, but there's at least 8. There's a minimum of 8 missing devices. So we need to show them on the drawing. Right, so we already learned that the janitor's closet is missing a device. But there it is drawn in. I have not drawn it on with the correct symbol because, well, I'm just demonstrating. But I could always do this. I could take a snapshot of it and bring it over here because I'm working with a PDF editor because this is what I use at work during the day as well. So I'm very familiar with these. I'm very comfortable with it. If you don't use PDF editors and things like that on a day-to-day basis at your job, don't worry about that. Do it on paper. Take a picture, convert it to PDF, send it to me. Absolutely acceptable. Just make sure that it's neat so I can figure out what's going on. Right? So we've got that added in, and then it's a fire zone 4. That's definitely drawn too big. So we'll bring that down a bit. And there it is connected. So I could also just connected it up there. That works as well. The functionality of the system hasn't changed. It's on the same pipe as other Fire Zone 4 things, so that's not an issue. Right? We are all good. Now, looking over here, I'm noticing these devices are on Fire Zone 6, so that looks like a fire separation as well. Right? So I'm going to draw that in as a fire separation. Again, just to make it a little bit easier to tell what's going on. You do have 2 copies of this. You can have a rough copy and a good copy, so that you can scribble in notes and everything as needed as you go. Right. So that's stuff that we have to look at. We have a minimum of 8 missing devices, and this is a group C occupancy and a group D occupancy. Right. So we have to be mindful of that. That's going to tell us what devices are missing. And that is the 3 sections of the assignment. We have the uh, identifying the devices and describing them. We have uh, the flagged conduits, which I recommend you do last, and we have our missing devices, which you get filled out in the table and put on to the drawings. Now I want to see the missing devices put onto the uh, plan view like we did here, but we also need to see it on the riser diagram, right? So we've got it drawn here coming off of the superintendent's office 418 over to 417. So we need to draw that into the riser diagram as well, right? So I can, if it can ever, there you go, concentrate. So I can find room 417. Right, so there's 417. Uh, the rate of rise and fixed device, and there is the device that was missing, and there it is drawn in on the line, and then we're going to call that was, I believe, 418. So oh, definitely want to make that a smaller font, and we're going to knock it a little bit crooked to make it cool like everything else. There we go. Well, or I can just oops, draw an arrow over to it. Right? So long as it's neat as you can make it. Then I'm just going back to double check. Oh, 417. Oh, it was already on there. 417 to 418. Huh. I must have added it in at some point. Oh no, that's a typo. Okay. Okay, so this should say 418 here. That's a typo on the drawing. There we go. 418. Fixed it. Okay, so that's what I want to see done. I want to see the missing devices put on the floor plan and on the riser diagram. And that's to make sure that we don't have any errors when we go to do our flags, right? We put them in both places, so we're golden. This particular device is not affecting our flags because flag one is over here, flag two is over here, and we're not adding any wires to either of them, but you never know. So we have to be mindful of that. So that is our three sections. And I will be sending out the soft copy of this so that you can use it if you wish, and you can double check on things. If you have questions about the assignment, you all have my email address. Drop me an email. If you have something that you're not sure of, you want clarification on, I will respond to it as quickly as I can. And help to guide you in the correct direction. I'm not going to give you the answers uh, completely because, well, that's not the point of the assignment, but I am definitely going to help you. You don't need to struggle, right? This is an assignment for learning. And when is it due? Good question mark. When is it due? So today, what day is today? Today is the 12th. Today is the 12th of March. We need a calendar. Oh, I have a calendar. Uh, There we go. So we've had to make some modifications a little bit. So February, we're not in February, we're in March. So we're most March 12th, and that was actually was that module seven? Did we just yeah, it was module seven. Well done, Mark. That was because I adjusted it. That was module seven and the assignment. Next week we're going to be talking about module eight. The 26th we're going to be talking module five because we haven't talked about that one yet. And then on Wednesday, April 2nd, we're going to be reviewing the assignment. So if the assignment is being reviewed on April 2nd, I need time to grade the assignments and send them back to you. So the assignment is due on Friday, the 28th of March. And it's very easy for me to tell if the assignment is late or not, because if you send me the email with your assignment and it's dated on, received on the 28th, it's on time. If it comes in on the 29th, it's late, right? Because I will not be grading the assignments until Saturday morning on the 29th. I'll be getting up and enjoying a coffee or several, and then I will be marking the assignments. So they are due on the 28th by midnight. Uh, I recommend you get them done a little bit early. Definitely don't leave them until the very end because if you run into submissions issues, you need a chance to ask questions and maybe do some revisions. There are two classes between now and when the assignment is due. So there is time to ask questions in the classes as well. You have a question, you ask the question. For example, we already have a question. Is it group C only within the confines of his living area? No, the entire building is considered to be group C. That's why we have all those extra heat detectors. If it was just a group D occupancy, we would not have heat detectors in all the offices. But because it's group C, everything applies, which is, well, uh, it's kind of ridiculous. Uh, he wants to have a you know, weird kind of creepy apartment right by his office there. And how much money is that costing to do that? Right? Just looking at the cost of adding all those devices on the fire alarm system, like this is pretty expensive. So hopefully the CEO's got a pretty profitable company because it's just a little bit weird. Hire a driver and get a ride home. Yeah. So uh, I know we went over the assignment fairly quickly, but I definitely hit all the important points. You're going to have to take some time to have a look at it. So get started as soon as you can. If you got time tomorrow, get started. Definitely look at it this weekend. Don't put it away and ignore it. Start having a look at it, noodling around. You have those rough copies, so you can have a look through everything and start to make notes so that you're not struggling to get it done. You don't want to be up super late on Friday the 28th, trying to get it submitted before midnight. Uh, on average, it's 4 to 6 hours of real work to do the assignment, right? That's not 4 to 6 hours sitting in front of the TV, watching the hockey game, drinking beer, and doing the assignments. It's 4 to 6 hours of real work. So make sure that you plan accordingly. It might take you a fair bit longer, depending on your work style, your learning style, and your experience level. I can knock this assignment out in about 15 minutes at this point, but uh, I've been doing this assignment for quite some time, and I've been doing fire alarm for a very long time. So that is not an accurate reflection of how long it should be taking you. And I can get it done really quick because I'm not going to ding myself on neatness, but For you guys, neatness counts because I need to be able to understand what's going on without having to puzzle things out because I don't like puzzling things out when I don't have to. And I'll just go, I don't know what that means, and mark it as wrong. So make it as clear as you can. Um, so don't leave it to the last minute. Spend time on it. Ask questions if you're not sure. Right? All the information is in our course books, so you can look it up, make references, make notes, all that stuff. So that is all that I have for tonight. It's been a long one tonight. We're at 9:13 p.m. So thanks for stopping by, everyone. And unless you send me an email with questions, I will talk to all y'all next week.